Somewhere right now, while you're watching this video, it's raining in the Amazon basin. Not just any rain, but the kind that the forest has created for itself. Trees draw water from the soil and exhale it through their leaves into the atmosphere, where it gathers into clouds and falls back down. The Amazon produces half of its own precipitation. This isn't a metaphor or poetic exaggeration. This is literally how it works. The forest creates its own weather, its own climate, its own water cycle. It closed the system long before we learned to build aqueducts. Now, let's start talking about scale. Because everyone knows the Amazon from textbook pictures, a green spot on the map of South America, parrots, vines, something tropical. But when you start digging into the numbers, it gets unsettling. The Amazon basin covers about 7 million square kilometers. That's more than all of Western Europe combined. Please like and subscribe to the channel. If the Amazon were a country, it would rank among the 10 largest nations in the world. And within this territory, there are approximately 390 billion trees. Not millions, billions. That number is so large that it's easier to say this. There are about 50 Amazonian trees for every person on Earth. They're standing right now, pulling water, processing carbon dioxide, and releasing oxygen. About 6% of all the oxygen on the planet is produced here, in this green cauldron, where the humidity is so high that clothes get soaked in minutes, and the air is drinkable. But oxygen is just part of the story. The biomass of the Amazon forest holds between 150 and 200 billion tons of carbon. That's carbon that hasn't entered the atmosphere, that hasn't become part of the greenhouse effect. The forest has intercepted it and hidden it in trunks, roots, leaves, and in the soil beneath. Remove this forest, and all that carbon will end up in the air. No one wants to seriously discuss the consequences of this scenario because they're too frightening. Now, let's mentally descend beneath the canopy. From above, from space, it looks like a solid green carpet, but inside, it's a multi-story building. The upper layer, where the crowns of the tallest trees catch all the light. The second layer below, where epiphytes live, plants that don't touch the ground at all, growing directly on the branches of other trees. Orchids, ferns, mosses. They've all settled up high because there's no point in even trying down below. Less than 2% of sunlight reaches the forest floor, to the very bottom. 2%. It's always dim, always humid, and life there is completely different, slow, fungal, and unnoticed. In this dimness resides about 10% of all known species. Every 10th species on the planet lives here. Every butterfly, every frog, every beetle that scientists have described and cataloged, every 10th of them is Amazonian. And that's just those we've already found. By the most modest estimates, hundreds of thousands of species of insects, fungi, and microorganisms remain undescribed. We literally don't know what lives there. Now let's talk about the inhabitants that send shivers down your spine. On the surface of the Amazon rivers, in the murky water that smells of decaying leaves and wet clay, lies a caiman, motionless, like a log. Its eyes barely protrude above the water, and it can remain still for hours. But its jaws can exert pressure of nearly 1,500 kilograms per square centimeter. For comparison, that's about 3 times stronger than a great white shark. The caiman doesn't chase its prey, it waits. And when the moment comes, the victim doesn't have time to understand what's happening. Above all this, above the crowns, above the clouds of steam that rise from the forest in the mornings, flies a harpy eagle, the monkey-eating eagle. With a wingspan of over 2 meters, claws longer than those of a grizzly bear, and diving speeds through the branches of up to 80 kilometers per hour. This predator snatches monkeys from the trees at full speed. It enters the canopy like a rocket and emerges with its prey in its claws. In the world of birds of prey, few can match its combination of power and maneuverability. And here you are, mentally standing in the midst of all this. Water with caimans below, a wall of trees in the dimness around you, and a harpy eagle above. And then the rainy season begins. The river overflows its banks. This happens every year, and the flood zone covers up to 350,000 square kilometers. An area the size of Germany is submerged. Fish swim into the forest, feeding on fallen fruits. Trees stand waist deep in water, and it's all normal. They've adapted to this over millions of years. This is the normal rhythm. The forest breathes, flooding, receding water, flooding again. Like inhaling and exhaling. A separate story is Angel Falls in Venezuela, at the very edge of the Amazon world. 979 meters of free-falling water. The highest uninterrupted waterfall on the planet. The water falls from such a height that part of it simply doesn't reach the ground. It turns into a cloud of tiny droplets that disperses in the air. Surrounding it are tepui, table mountains with flat tops, around 2 billion years old. On their summits grow species that are found nowhere else on Earth, because these plateaus have been isolated from the rest of the world for millions of years. They are islands in the sky, each with its own evolution. When you stand next to something like this, even mentally, even on a screen, it's hard not to catch one unpleasant thought. Everything we build, everything we take pride in, skyscrapers, bridges, dams, is a rough draft compared to what nature has done here for 2 billion years without a single blueprint. The tepui stood when there was nothing on Earth more complex than bacterial films. The Amazon flowed when the first dinosaurs were still hundreds of millions of years away. We arrived here yesterday in geological terms, and for some reason, we decided we could take charge of it. But that's a discussion for later. For now, remember the scale: 7 million square kilometers, 390 billion trees, 10% of all species, a forest that makes its own rain. This isn't just a tropical forest from a documentary. This is a life support system for the entire planet. And it's working right now while we're talking. There's an animal called the three-toed sloth. Everyone laughs at it. Memes, jokes, a symbol of laziness and uselessness. But if you look closely, this creature is a survival genius, far beyond us. Its metabolism is so economical that one leaf can take up to a month to digest. Not a day, a month. Its body temperature can drop to 30 degrees, which is almost unimaginable for a mammal. It moves so little and so slowly that its fur hosts over 80 species of fungi and algae. This isn't dirt or disease, it's an ecosystem. A living, functioning ecosystem right on one animal. The algae give its fur a greenish tint, allowing the sloth to blend in with the surrounding foliage. Predators simply don't notice it. In other words, its strategy is to be so inconspicuous and so economical that death isn't worth pursuing it. And this strategy has worked for millions of years. Capuchins, on the other hand, have a completely different approach. These monkeys are engineers. They take stones and crack nuts with them. They find sticks and poke around in crevices to extract insects. And most importantly, they teach their young. Not by instinct, not genetically, but by showing them with their hands. A mother takes a nut, places it on a flat stone, strikes it with another stone, and the young one sits nearby, watching. Then it tries itself, awkwardly, clumsily, dropping the stone, missing, but after a few weeks, it starts to get the hang of it. Researchers have observed this for over 25 years, and now confidently say, this is culture. Not instinct resembling culture, but culture, a set of skills passed down through learning, not through genes. Different groups of capuchins even have different techniques. Some crack nuts one way, others another. It's like dialects, but in stone tools. Next is color. In the Amazon, color isn't decoration, it's a language. Red on a frog's skin means one thing: don't touch, you'll get poisoned. Brown on a butterfly's wing says, I'm not here, I'm a piece of bark. And a bright blue flash when a creature takes off. That's a decoy. A predator focuses on the color spot. And when the prey lands and folds its wings, the colored spot disappears and the predator loses its target. 3 colors, 3 survival strategies, and each has been honed over thousands of years. Among those who openly wear bright colors is the Scarlet Ibis. Red and blue, yellow and green, it flies above the canopy like a living sign. But behind this beauty lies serious engineering power. The ibis's beak can exert pressure of over 500 kilograms per square centimeter. It cracks shells that a human couldn't break without a hammer. And in the process, the ibis does crucial work for the forest. It disperses the seeds of large tropical trees over vast distances. Without it, the forest would look different. And that's not an exaggeration. But now we get to the truly interesting part, connections. Here's the Brazil nut. Its fruit weighs up to 2 kilograms and falls from a 50-meter tree. When something like that comes crashing down, it's best not to stand underneath. The shell of this fruit is so hard that no large animal can crack it. None, except for the agouti. This small rodent, resembling a mix between a rat and a rabbit, has enough jaw strength to gnaw through this armor. The agouti eats some of the nuts and buries others in the ground for a rainy day. Like a squirrel with acorns, only in the tropics. And just like a squirrel, it forgets about half of its caches. From these forgotten nuts, new trees grow. But that's not all. For the Brazil nut to bear fruit at all, its flowers must be pollinated by a specific bee, the orchid bee. Not just any bee, but this particular species. Without it, pollination doesn't happen. Remove the agouti, there won't be new trees. Remove the bee, there won't be fruits. Remove the tree, the agouti loses food, and the bee loses its flower. 3 completely different organisms are connected in such a way that without any one of them, the chain breaks. And there are thousands of such chains in the Amazon. Even lower, beneath all this, an army is moving along the forest floor. Literally, nomadic ants. Colonies of 600 to 700,000 individuals that don't build permanent homes. They march through the forest in columns up to 20 meters wide, consuming everything alive in their path. Small insects, spiders, scorpions, everything that hasn't managed to escape. At night, they stop and build a temporary shelter out of their own bodies. The ants cling to each other with their legs, forming a living ball, inside which the queen and larvae hide. In the morning, the ball breaks apart, and the army continues on. But even more astonishing are the leafcutter ants from the Atta genus. They have existed for 50 million years. 50 million. For context, our species, Homo sapiens, has existed for about 300,000 years. These ants have been here 160 times longer than us, and all this time, they've been farming. They cut pieces of leaves, carry them to an underground nest up to 8 meters deep with thousands of chambers, and grow fungi on these leaves. Not by chance, not spontaneously, purposefully. They fertilize the substrate, maintain temperature and humidity, and remove infected areas. This is a fully functioning farm. The volume of soil that one colony moves while building its nest is comparable to the work of an excavator. And you know what? Their system has never failed. 50 million years, and not once has it needed rebranding, crisis management, or a board of directors. We invented agriculture about 10,000 years ago, and in that time managed to deplete a third of the world's arable land. Maybe we should be a little less proud and a little more observant. All right, let's leave the land, to the water. The Amazon River dumps about 209,000 cubic meters of water into the ocean every second. Every second. That's more than the next 7 largest rivers in the world combined. The flow is so powerful that fresh water dilutes the Atlantic Ocean up to 160 kilometers from the shore. You step into the open ocean, surrounded by salty water, but beneath you is fresh Amazonian water that hasn't mixed yet. This river is home to over 3,000 species of fish. For comparison, all of Europe has about 500. In one river, 6 times more than on an entire continent. Among them is the arapaima, a fish up to 3 meters long with scales so tough that they can withstand a piranha's bite. And the Amazon River dolphin, the boto, pink, blind in murky water, using echolocation, with a brain that is 40% larger than ours, relative to body size. As darkness falls, the forest completely transforms. Daytime inhabitants fall asleep, and those who see in the dark come out. The ocelot, a spotted cat whose vision is 6 times more sensitive than that of humans. Where we see complete blackness, it sees every branch, every leaf, every movement. Nearby, a kinkajou climbs along the branches, a nocturnal creature with a 12-centimeter tongue that it uses to extract nectar from deep tropical flowers, while also transferring pollen. And a little further down the branch, a podo freezes, and no one will find it because it can remain motionless for hours, becoming indistinguishable from an ordinary twig. This forest never stops. Daytime has one shift, nighttime another. Every creature is integrated into the overall scheme so tightly that if you remove one, everything around it starts to collapse. We're used to thinking of nature as a backdrop, as a decoration for our lives. But here, it's the opposite. We are the decoration, and the forest is life. Here's a fact that shatters everything you thought you knew about geography. The Amazon didn't always flow eastward. About 10 million years ago, it flowed into the Pacific Ocean. It flowed in the opposite direction. Then the Andes rose. Young mountains grew like a wall in the west, blocking the river, and the water turned around. It found a new path and flowed across the entire continent to the east, into the Atlantic. The river that seems eternal and unchanging has actually completely changed direction. And it has done so more than once in its history. The landscape we perceive as a given, as something immobile, is actually fluid, like the water itself. And that's not the only surprise beneath the surface. In 2011, scientists discovered that beneath the Amazon, at a depth of about 4 kilometers, there's another river. They named it Hamza. It flows parallel to the Amazon, only much slower and much deeper, an underground river nearly as long as the Amazon itself. We walk on the surface and think we know this territory, while beneath our feet lies an entire hydrological world that we learned about just yesterday. But if we can come to terms with geology, well, ancient history, millions of years, the next thing hits closer to home. In 2018, a group of archaeologists conducted LiDAR scanning of the southern part of the basin. LiDAR is a laser that sees through the forest canopy and reveals the terrain beneath the trees. And there, beneath the crowns, more than 80 geometric earthworks were discovered. Moats, mounds, platforms of regular shapes dating back about 2,000 years. Someone built them. Someone lived here in an organized society, planned, constructed, cultivated the land. And we didn't know this because the forest concealed everything. These people, by the way, weren't just inhabitants of the forest. They were its engineers. They created a soil called Terra Preta, black earth. They took charcoal, mixed it with organic waste, bones, ceramics, and incorporated it into the soil. This soil retains its fertility to this day. After 2,000 years, it's several times richer than the ordinary Amazonian soil around. We can't replicate this on an industrial scale today. We have fertilizers, combines, satellites, agronomic institutes, and that technology still works better. Researchers estimate that before the arrival of Europeans, between 8 and 10 million people lived in the basin. After contact, up to 90% of them died from introduced diseases, smallpox, measles, influenza. In just a few generations, civilization simply vanished, and the forest, in a couple of centuries, reclaimed everything with greenery, hiding cities and roads so well that for 400 years, we thought no one had ever been here. Nature doesn't care who you are or what you've built. It operates at its own rhythm and doesn't keep archives. Now, let's talk about those who are truly dangerous in this forest. The black caiman, up to 5 meters long, over 400 kilograms. The main predator of the Amazon rivers. In the 20th century, it was nearly wiped out for its skin, which was used for bags and belts. The population plummeted to critical levels. But then hunting was banned, and the caiman returned. Slowly, generation by generation, but it came back. This is a conversation about how nature can recover if we simply don't interfere. And alongside predators lies beauty that's hard to look away from. The Scarlet Ibis, a bird of such a rich red color that it seems painted. It gets its coloration from carotenoids in the crustaceans it eats. Literally, you are what you eat. Nearby is the rock rooster with a bright orange crest. Males of this species hold mating tournaments on special grounds called leks. They dance for hours, jumping, fluffing their feathers, making clicking sounds, while females sit around and choose the best. This is a talent show that has taken place in the forest every season for millions of years. And the quetzal, a bird with tail feathers up to a meter long, was valued higher than gold by pre-Columbian civilizations. Quetzal feathers were currency, a symbol of power, and a sacred item. Gold could be mined from the earth, but this bird had to be found in the cloud forest at 2,000 meters high. Now let's move to something that seems simple at first glance, the color of a wing. The blue morpho butterfly isn't blue because it has blue pigment. It has no blue pigment at all. The color is created by nanostructures on the wing scales. They refract light so that only the blue spectrum is reflected. This isn't paint, it's physics. And now engineers are copying this structure to produce anti-glare coatings for screens and optical sensors. A butterfly that weighs less than a gram accidentally invented a technology that we only reached in the 21st century. The chemistry of the forest also deserves a separate discussion. The golden poison dart frog, about the size of a thumb, bright yellow, and its skin contains enough toxin to be dangerous to 10 adult humans. It doesn't produce this toxin itself. It gets it from the beetles of the Courcine genus that it eats. If raised in captivity on a different diet, it's completely harmless. The poison isn't its property, it's a property of the environment in which it lives. The Ticuna people in the Colombian Amazon use over 500 plant species for medicine. Compounds derived from Amazonian plants have formed the basis for drugs against malaria and glaucoma. The pharmaceutical industry still comes here for clues because the forest has tested so many chemical combinations over millions of years that no laboratory could replicate in centuries of work. A separate category is the masters of camouflage. The leaf-tailed gecko presses against a trunk, and its skin becomes indistinguishable from the bark covered in lichen. You can look at it up close and not see it. A stick insect 35 centimeters long sways in the wind along with a branch, and no bird can tell it apart from a dry twig. And a caterpillar of one of the tropical butterflies has learned to do something that sounds like a fiction. It inflates the front part of its body and resembles a snake's head. With eyes, with a characteristic shape, with movement, a bird sees a snake, gets scared, and flies away. The caterpillar stays alive thanks to bluffing. Nature invented acting long before the first theater. The sanitizers of the forest work around the clock. The giant otter, up to 1.80 meters long, hunts in family teams, controlling fish populations. The The freshwater stingray with a disc over 1 meter in diameter digs through the bottom, processing sediment. The dung beetle drags organic matter back into the soil, completing the nutrient cycle. Each of them is a link in the chain, without which the system would start to choke on its own waste. And here's the conclusion that's hard to say but necessary. Since 1970, about 17% of the Amazon forest has been destroyed. In 2023, the basin was hit by a record drought. Rivers shrank so much that their beds were exposed, and over 150 river dolphins died. These were the very botos, with brains larger than ours. But there's another side. In areas where logging has stopped, the forest is returning, and it's doing so at such a speed that scientists themselves are amazed. Secondary forests, those that grow back after destruction, absorb carbon 11 times faster than old untouched stands. The forest isn't just recovering, it's rushing to recover, as if it knows that time is short. This system has survived ice ages. It has survived the impact of an asteroid that wiped out the dinosaurs. It has survived the rise of mountain ranges and the reversal of rivers. If we just take a step back, just stop burning, cutting, draining, the forest will do the rest itself. It knows how. It has done this millions of times. Because as long as the Amazon breathes, the entire planet breathes. And this isn't a pretty phrase for a poster. It's a literal, physical, measurable fact.